All right, now we're going to move on to understanding the mean, which we also call the expected value. You're going to see that throughout the entire class that we have the mean of something is often called the expected value, okay? The mean or the expected value of a uniform probability distribution, and then we're also going to calculate the standard deviation. These are very simple formulas. I know you're looking at this one saying that's not that simple. Actually, it is pretty simple. It doesn't have any sums. You don't have to sum together 17 things. You're just going to do a simple calculation. So the mean of a uniform probability distribution, it's very simple. The mean is equal to b plus a divided by 2, where b is the maximum value in the range and a is the minimum value in the range. So you do the larger number of the range plus the smaller number and divide by 2. That's the mean. The standard deviation is you take the larger value b, subtract the smaller value a. Now note, this is just the range. So, you're taking the range of the distribution and you're going to square it, and then you're going to divide by 12, and then you're going to take the square root of that number, and that's going to give you the variance, okay? So let's say, look down here, suppose we have a random variable x, and it's best described by a uniform probability distribution with a range from 9 up to 16. And we just did this in the last video, the range 9 up to 16, and we knew that the probability density function was 1/7, right? Okay, that was our probability density function. So what is the expected value? Well, all we have to do to find the expected value is add together 9 plus 16, okay, so it'll be 16 plus 9 divided by 2. And 16 plus 9 is, let's see here, is 25. So it's 25 divided by 2. And 25 divided by 2 is 12.5. And so the mean of this uniform probability distribution is 12.5, okay? To find the standard deviation, we're going to plug 16 in for B. We're going to plug 9 in for A, and so the standard deviation is going to be the square root of 16 minus 9, and then that's going to be 7, and we're going to square that number, divide by 12, okay? So this is going to be the same thing as the square root of 7 squared. 7 squared is 49, 49 divided by 12, and we can do this now in the calculator. Let's go to the calculator and do the square root of 49 over 12. So the square root of 49 over 12. And that's going to give us 2.020726. 2.020726. So 2.020726. And that is the standard deviation of this this situation down here, this uniform probability distribution that runs from 9 to 16. All right, so I'm going to scroll down here and I'm going to bring those answers down here. It says, what is the expected value here? Well, the expected value mu is 12.5. And what is the standard deviation? Standard deviation is 2.020726, okay? And what we're now going to ask, this is the last question that we're going to ask, is this is the last kind of question you're going to see, at least in lesson 9. It's going to look like this. It looks a little strange. It says, what's the probability that x is between? Remember, anytime you see this, whenever you see this, where x is greater than something but less than something, this means x is between, okay? X is between is what this means, okay? So what is the probability that x is between mu minus the standard deviation? So this is the mean minus the standard deviation, and the mean plus the standard deviation. Well, we can find out what these are, the mean minus the standard deviation. Mu minus the standard deviation is 12.5 minus 2.020726. 2.020726. 0.0726. So if we do this in the calculator, okay, we're going to do 12.5 minus 2.020726. That gives us 10.479274. Let's look at that again. 10.479, 10.479, 274. And now we got to do mu plus the standard deviation, okay? So that'll be, so mu plus the standard deviation is going to be 12.5 plus 2.020726. And let's see what that gives us. So what I'm going to do here is I'm going to go up and I'm going to grab this question here, the one we already did, and I'm going to go over and I'm going to change the minus to a plus. And that's going to give us 14.520726. So it'll be 14.520.520.726. Okay. So what this is saying right here, what this is saying is, what is the probability that x is between 10.479274 less than or equal to x less than or equal to 14.520726. That's all that's saying. And we know how to do this. We did something just like this previously. I'm going to make some room here so we can do this calculation. Remember, the way that we calculate area, or probability, excuse me, is by using area, okay? So remember, the way that we do this is we do the probability distribution, which is 1/7. And then we're going to do the larger number, 14.520726, minus the smaller number, 10.479274. And I'm going to show you a trick what this winds up being. Watch this. 1/7 times, what's happening here is this actually winds up just being 2 times the standard deviation, and I'll prove it to you. I'm going to go ahead and, so this is 2 times the standard deviation. So I'm going to go into the calculator and I'm going to grab this number and subtract minus. I'm going to go up and grab this number, execute, and it's 4.041452. Well, watch this. I'm going to go up and grab the standard deviation here, which is this. Okay. I'm going to grab this number and I'm going to multiply it by 2. I'm just going to double it. And look, 4.041452. So you can shortcut this when you're doing this. What you're really doing here is you're finding the probability of 2 times, or sorry, hang on. I did this wrong. What you're really doing here is you're really just doing 1/7 times 2 times sigma. That's what it is, okay? And so we'll have here 4.041, 4.041, 452, 452, okay? And we'll do this in a calculator. We'll do 1 divided by 7, close parenthesis, times 4.041,452. And what we get is 0.57735. 0.57735. Okay? And so now this is everything that you have to be able to do. And what we're going to do right now is we're going to move on to basically an example where we do the whole thing in one shot. I know this looks like a lot. You're like, that's a lot. It's actually not. When we do this example in just a minute, I think you're going to feel like you can do this. All right, let's work through this question here. This is basically what you're going to have to do. Stuff like this in the homework. It says, suppose a random variable x is best described by a uniform probability distribution with range from 31 up to 72. And so 31 would be our A and 72 would be our B, okay? So the first question is, well, what is the range of the probability distribution? Well, the range, very simply, is just the larger number, 72, minus the smaller number, 31. And 72 minus 31, if you did that in a calculator, it would be 41. So that's our range. What is the probability density function? Well, the probability density function is f of x equals 1 over the range. So it'd be 1 over 41. All right, we're moving on. What is the mean? Well, the mean, we said, is going to be equal to b plus a. So that's 72 plus 31. So we take the larger and smaller number, add them together, and divide by 2. Well, 72 plus 31, that's 103. So 103 divided by 2 is equal to 51.5. And therefore, the mean is equal to 51.5. What is the standard deviation of the probability density function? Well, the standard deviation is equal to the square root of basically the range, 41 squared over 12. Okay, so 41 squared over 12. Well, let's go over to the calculator and do this. We're going to do the square root of 41, that's the range, squared, divided by 12. That's how we calculate the standard deviation. And that's equal to 11.83568. I'm going to stop at 5 here. Okay, 11.83568. 83568. 11.83568. Let me check that again. 83568. Okay, excellent. All right. And now we want to do, well, what is the probability that x is less than 57.4. So because it says less than, that means that the bottom end of this interval is going to be A, which is 31. So this is going to be from 31 up to 57.4. So we're going to take the probability density function, 1 over 41, and we're going to multiply it by 57.4 minus 31. And that's the same thing as 1 over 41 times 57.4 minus 31 is 26.4, and you can verify that in a calculator, but it's correct. And now we're going to go over to the calculator and do 1 over 41 and 26.4. So 1 divided by 41 times 26.4. And that gives us 0.644. We're going to stop. Actually, let's go out to 6. 0.643902. 643,902. 0.643,902. Okay? All right, let's try another one. All right, so we're going to scroll down here and look at some other probability questions here. All right. So we have the probability. We have 6 more or 5 more, it looks like, probability questions here. And this one here says, what is the probability that x is less than 43.9? Well, since this is a less than, it's going to be identical to this less than, only instead of having a 57.4 here, we're going to have a 43.9. So it's going to be 1 over 41 times 43.9 minus 31. Okay? So 43.9 minus 31, that's going to be 12.9. So we're going to have 1 over 41 times 12.9, which we can do over in the calculator. We'll do 1 divided by 41, and then we'll close the parenthesis, times 12.9. what did it say? 12.9, okay? 12.9. And that's going to give us 0.314634. 314634. 0.314634. Okay, let's move on to this one here. This one's an easy one. This is the probability that x is equal to 62.8. Remember, in a continuous random variable, we cannot do an equal. So the answer here is automatically 0. All right, this one says that the probability that x is greater than 32.9. So in this case, our interval is going to start at 39.2 and go up to, what was our number? What was our other number? 72? Our upper is 72. Yep. All right, so we're going to do from 39.2 up to 72, okay? And so what we're going to have here is 1 over 41 times 72 minus 39.2. And so that's going to be 1 over 41 times, well, 72 minus 39.2 is 32.8. And you can verify that in the calculator if you want to, okay? Now we're going to move over to the calculator and we're going to do 1 over 41, close parenthesis, times, what was our number? 32.8 times 32.8. That's going to give us 0.8. That's an easy one. And that's just going to be 0.8, okay? Now we're going to do another x is greater than, so we're going to do it the same way. It's going to be 72 minus, but instead of 32.9, it's going to be 68.6. So it's going to be 1 over 41 times 72 minus 68.6. So we'll have 1 over 41 times, and 72 minus 68.6 is 3.4. 3.4. And so we'll go over here, the calculator. We'll do 1 divided by 41, close, times 3.4. And that gives us 0.08292. We're going to make this 927. 927. 0.08297. 0.08297. Okay. All right. Now we've got a between here. And so basically what we're going to do is when we do the subtraction, we're going to do 55.4 minus 42.7. So again, it's going to be 1 over 41. We always start with the probability density function times the upper limit of the internal interval, which is 55.4, minus the lower limit, which is 42.7. I'm going to show you what you can do in a calculator. I'm going to go ahead and key this in exactly as we see it. So I'm going to do 1 divided by 41, and then I'm going to close the parenthesis, times, then I'm going to open a parenthesis again, just like I have here, 55.4 minus, and then 42.7, 42.7, close parenthesis, execute, and it just gives me my answer, 0.309756, 309,756, 0.309756, okay? Then the last one we're going to do here is our probability. We saw this before. Remember, this is just it's a special thing to understand about, not about all kinds of probability density functions. It's where x is between the mean minus the standard deviation and the mean plus the standard deviation. And I want to remind you that the way we found this is it's always going to wind up being the probability density function times 2 times whatever the standard deviation is. This is going to be 1 over 41 times 2 times, all right, let's see if we can remember what is the standard deviation here. It's 11.83568, 11.83, and in fact, I'm going to grab this. Okay, let's use this little tool here. I'm going to copy that, and then I'm going to move down here, and I'm going to paste it. I'm going to paste it right here. There we go. All right, good. All right. So we're going to do 2 times 11.83568. And we can just key this in the calculator just as we see it. So let's look at it. It's going to be 1 divided by 41, close parenthesis, times, and in parenthesis I'm going to do 2 times 11 point, let's see, whoops, wrong button. Here we go. 83568. 83568, close parenthesis. So let me show you what I have here. This is 1 over 41, that's probability density function, times 2 times the standard deviation. And we get 0.57735. Oops. 57735 is our final answer. And that's it. That's everything that we have to be able to do with the uniform probability density function in this particular lesson.